You know it's a beefy cooler when you can drum on the box. You know what, guys? I got new merch. It's available now, crowdmade.com/Jayztwocents. We got zip-up hoodies, we got tri-blend, we got a new logo. I digress. Since 2012, it's a digress logo. You guys have been asking for that. Anyway, we got all kinds of stuff. Zip-up hoodies, beanies, polos. Don't take my word for it, because obviously I can't do this ad. So just look in the description below and you guys will find the link. Thanks. All right, so if we take a look inside here, well, okay, so here's the deal. There should be nothing to assemble on this. Here are the mounting brackets and stuff. It of course supports all of your standard sockets, 2011, 2066, AM3, AM4, TR4, maybe? We'll check. This thing is gargantuan, holy crap. Now this is an AIO. It's fully assembled. It is expandable. This is based on a 280 millimeter radiator design from AlphaCool. We've got this nice honeycomb sort of a grill protection on here so you don't smash your fins. You can see here we've also got in collaboration all of my fingerprints or something on that. Holy crap, we'll have to clean that off. Be Quiet fans are actually used in here, or as they like to call them, Eiswind. The Eiswind fans are in here, making the air move through with all the static pressures needed to get all the maximum cooling. So it has these quick disconnects right here that I've never actually used. How do you use these guys? So yeah, they're not really quick disconnects, they're just disconnects nonetheless, and you lose a couple of drops of water as you just saw right there, but that makes this expandable. Expandability is kind of key because these are off-the-shelf water cooling parts. It is a custom loop as an AIO. Now, no, they are not the first to do this. At least the Eisbaer is not a new concept. EK did something similar to this, and I think, to be fair, AlphaCool / Tuning did something quite a while ago as well. But the Predator 240 and 360, which we took a look at a while back, was also the same concept of off-the-shelf parts put together as an AIO. This water pooled up in there. That is expandable and allows you to add things like graphics cards or other radiators or whatever may be the case. These are two very different approaches. So the Predator was sort of a failure. I don't know if you guys remember that. I did a video about it. EK had to end up warranting a lot of systems because they leaked. There was a problem with the block or something like that. And so it was sort of reborn as the Phoenix. Phoenix came out in 2017 using pretty much a lot of the same parts as the Predator, but it was an upgraded block design and whatnot. But my problem with the Predator, and I don't know if this persisted on the Phoenix, was they used what looked like a DDC on the end of the radiator tank. But it wasn't a true DDC. The pump internals were different. They were lesser quality than a DDC. And we found that out when I built this test rig, because what I did, you guys can go back and watch this video. You'd have to dig it up. I'm not gonna put the link, but you can find when I built this test rig, the pump that's down here is actually out of a Predator. I didn't have a DDC, but I had this top from AlphaCool. This is an AlphaCool unit right here that's been running now for like 3 or 4 years in this setup. And the pump is actually out of a Predator. And that's when I found like, wow, it didn't work in here because the housing was slightly different. So that's one of the things that kind of concerned me, was they were able to cut costs when making an AIO like that by using lesser grade parts. Now AlphaCool is using a D5 style pump, which we will take a look at. It's the VPP 755 V3, not to be confused with the older 755 or VPP 755, which was actually kind of garbage. This is a much better redesigned PCB. Everything about it is different, which they say is making the reliability of it much, much better. So let's do this. Let's go ahead and open it up before we actually get it onto our test rig to see how it performs on our 8700K. Oh, I forgot to mention too, these are G-quarter threaded fittings right here. So against all of my better judgment, I've decided I'm just gonna keep disassembling. There we go. So there it is. This is the VPP 755 V3 pump, which is very much a D5 style pump. It is a PWM. You can see how these are just drop-in Be Quiet fans. I believe these are Silent Wings? Yeah, Silent Wings 3. Okay, so it's all hooked up here. The retention system, pretty straightforward. It's a back plate with a pass-through, blah, blah, blah. Read the instructions for your particular mounting style. Obviously with AMD and all that, it's a little bit different for each socket. But we found out what the LED is for, so I've got the actual pump hooked up to a different power supply so I can turn it on independently and actually show you what the pump sounds like. Because the pump can make a sound that's sometimes very intrusive. Like DDCs are very high-pitched, very loud usually. D5s are usually a lot less audible, but they make a hum. So this is what this one sounds like. And pay attention to the window right here. There's a blue LED in there that turns on. Remember that strip that we saw? That you can actually see your water level in there. So that's the pump right there at full speed. Like I have to get my mic that close to it for you to hear it. But as you can see, that blue LED lights up your reservoir that's in there so you can keep an eye on your water levels. And when you're filling it though, it'll make it a lot easier, to fill it like this. This is kind of the orientation it would be intended to go in a case, usually at the top. Biggest issue you're gonna have with this though, before we get into the temperature test, is fitting this behemoth. Behemoth. Behemoth? We went through this before, didn't we? I feel like we've done this. Behemoth. Yay! So obviously it's the width of a 280 millimeter radiator, so it's 140 millimeter fans wide, but the extra width of the chassis built around it. I want to see if it'll fit in the R6. That's kind of where I think I might end up using this, but with my own fittings and reservoir, or not reservoir, but block and stuff to match the gold build, because I think this matches my solution of trying to get something that fits in there and looks decent. And I can paint all these external pieces gold to make it match, because gold, we like gold around here, obviously with the gold build. But obviously we're here to do a performance test, so I'm gonna go ahead and, turn on power to the system. Usually power is important. Okay, so we're installed and we're gonna kind of overclock this a little bit more, but I wanna kind of just start with some of the basics. So all cores are synced to 4.7, which is the turbo clock, but on the Asus motherboards, if you enable multi-core enhancement and then sync cores, you get 4.7 on all of them. 1.35 volts is where we are in the CPU. Normally, I would not recommend going any higher than that for 24/7 because a lot of coolers have a problem keeping that cool. Now, right now, we're gonna do a Cinebench run first, but then we're gonna overclock it till it's no longer stable. I'm gonna try and get 5 gigahertz out of this, and then we're gonna run AIO for 30 minutes. So right now, our package is idling at 29C, and our cores are in the mid to upper 20s, which is only a few degrees above ambient right now. It's about 68 degrees Celsius. Wow, it is burning hot in this room. Going into a little diatribe now about people asking me, Jay, why do you talk about temperatures in Fahrenheit when you talk about ambient, but then you talk about Celsius and PC? I don't speak Celsius, but I understand it for computers because I know the ranges things should be in, but I don't know what our ambient temp is because I'm sorry that our thermostats in America want to be different. Anyway, with that said, it's about 68 Fahrenheit. You can do your own conversion. And our system is running, like I said, in these high 20s when it comes to Celsius. Now, if we run Cinebench, which is an AVX instruction set, boom, spikes up to 66 on the package, low to mid 60s on the core, all the different cores, and it's just solid. Look at that, they're not even fluctuating that much. Okay, so we found our theoretical max right here, just in terms of temperatures and voltage and all of that. Okay, so here's what we got. We got 5.2. We're running 5.2 gigahertz right now, as you can see right there using hardware monitor. And the voltage to achieve that is more than I would ever recommend on any AIO or hell, even a custom loop. 1.4 on the V-core. Hey, that rhymes. I'm a rapper now. But the question is it gonna survive a Cinebench run? Let's see, cores right here. Packages in the mid 90s, 94, 93, 95. The fact is we passed at 5.2 by just moving voltage slider to 1.4. We were crashing at 1.38, so I don't think we can get away with any less. But here's the thing, 95, 97, we're still not at TJ Max. This chip is designed to be able to run all day, technically at 104C. At 105, it starts the throttle. I don't think AIO is going to, I think it's gonna crash, to be honest. So what I'm gonna do right now is I'm going to back it back down to 5 gigahertz, put the voltage back down to something reasonable that you would use on day to day, and see how this cooler does. Okay, so 5 gigahertz at 1.28 volts is what we settled on temperature-wise. As you can see, freaking amazing. 74 on the package, high 60s, mid 70s on the cores. All right, AIO incoming. All right, so here's what it looks like after 19 minutes. Interestingly, we got, the curve, if you draw a medium line through there, it kind of goes up a little right there and then sort of comes back down. The lows got lower and the highs, you can see right here on this line, didn't really go any higher than the highest. So what we think might have been happening here as this curve is sort of trending downward slightly is we think the thermal paste might have been setting in better because we just installed it and went. And it takes time for thermal paste to sort of kind of not really solidify, but sort of spread, fill in the gaps and cure. There is a curing process that happens with thermal paste. And we think that it's curing, and that's why we're seeing the lows go down right there. But if we go over here and we stop the test, you can see we did hit 90, 89, 90, 89, 89, 83. But our averages, look at our averages. 81, 71, 73, 70, 71. The average is more important than the maximum here, because this could have been those momentary spikes where when you're testing cache and you're testing FPU, like we literally were asking Extreme here, or Ada Extreme, to do an extreme cooling test. We asked it to just stress the CPU as high as you possibly could, but we passed nearly 20 minutes at 5 gigahertz at 1.28 volts with a temperature that is more than reasonable. I mean, the averages were absolutely phenomenal. And if you back this down to stock speeds, then it stays in the 50s and the 60s. All right, so we want to see how it does in games though, obviously, because AIOs and gaming computers are very commonplace now. So if we look, we're using Far Cry 5, which is known to be pretty CPU intensive. And with the level loading, we're seeing 72, 62, 57. So inside the actual rendered game, we're on the helicopter ride right now into wherever this cult country is. And you can see we are still sitting in the 60s, 40s, 30s. It's bouncing all over the place as you would expect with a game. Now running overclocked at 5 gigahertz on this, on just an AIO, yeah, obviously you could get away with this running overclocked while gaming. And the funny thing is, even when we had this test running for 20 minutes, the air that was coming through the radiator, and yes, we're sitting in an open environment because we want the radiator to be the only thing controlling temps, not some sort of case flow, is the fact that the air coming through here was always cold. It was always ambient feeling. So that means that the temperatures we were seeing were straight up package limited in terms of the IHS design, and the TIM used in the CPU on the 8700K is what was keeping us from getting any cooler, whereas there was very little saturation. So yeah, the Eisbaer, it's got a funny name, but it is definitely the beefiest AIO I've taken a look at yet. And again, it's not truly an AIO. It is off-the-shelf water cooling parts that you could go and buy independently and make a custom loop out of, that they've just already all assembled it for you. There's nothing different about this XPX block. There's nothing different about the radiator that's in here, or the Silent Wings fans are in here, or the 7PP, or whatever, the VPP 755 V3 pump that's in it. You could buy all of these independently and make your own custom loop. They just did it for you, and it's pre-assembled, comes with a warranty, and you don't have to worry about screwing anything up in your system. Expandable, and obviously performs really well. So I still think I might try and see if this fits in my R5 or R6 case and use this instead of trying to piece something together. Because I could paint this gold, or even leave the plastic part like this and paint the shrouds gold, and it would match, and it would definitely make my life easier in getting that all figured out. All right, guys, we're gonna go. Tell us what you think about this. I think the only drawback to it, quite honestly, is, well, there's two things. The price, it's about 280 US dollars. Equivalent to approximately what these particular parts independently would cost you for the fittings, the pump, the reservoir, the radiator, the block, tubing and all that, the fans. It's pretty much the sum of its parts. But the other thing is gonna be its size. It is definitely large. It is wider than 140 millimeter fans, and it is certainly longer than a 280 millimeter radiator, because you have the pump and the reservoir up in this section. So there's not a whole lot of cases that are gonna be able to fit this up top. Some might be able to fit it up front, but you're definitely gonna wanna look at the dimensions of your case to figure out whether or not it can fit the dimensions of this cooler. So sign off in the comments below what you think about AlphaCool's new Eisbaer. And yeah, like I said, this is an AIO that can beat up your AIO. You know, you have those bumper stickers that says, "My student beat up your honor student." My cooler can beat up your cooler. That's the film work. So you can probably cut. Behemoth. Behemoth.